Welcome back to PV Online. Today we're going to continue our discussion on kinematic calculations. All right, so we have our example here. Now remember, it would be wise to have the three kinematic equations written out. So I would have this on a sheet of paper. This top one is going to work for any condition, and the second and third one is going to work anytime your initial velocity is going to be 0. So as long as our initial velocity is 0, these two are going to work out fine. All right, the question is, it says what distance? So right off the bat, that's telling me I'm looking for the distance. That's what I don't know. And it says it's required for a train to travel if it starts from rest. If it starts from rest, that tells me my initial velocity is 0, which is good because then that means that these two equations will be fine, will work fine. And it accelerates at 0.25 meters per second squared. Remember that the unit is a guide. Acceleration has a unit of meter per second squared. So that means the number that I'm going to put in wherever a goes is 0.25. And then we have 120 seconds. And 120 seconds is going to be time, and I know that because of the unit. All right, so we have our variables. I've listed everything of importance. This is 0, so I really don't worry about him. And so I want to find out the distance. So we have to come over here and choose between these three equations. So now let's take a look at this. Would one be satisfactory? Could I solve for distance with this one? And the answer to that is no, because there's no distance in the equation. So let's go down to our next one. All right, I've got a distance here, which is good. 1/2 is just 0.5, so that's not anything I worry about. Do I have the acceleration? I do. Do I have the time? I do. That means that this second equation will work just fine. But let's just take a look at this third one. I can't use this equation because even though it's got a d inside the equation, I'm not given anything about a velocity. So this one's not going to work, neither will this one. So we're going to start by writing that the distance equals 1/2 the acceleration times time squared. So now all we need to do is substitute in the numbers for the letters. I'm looking for distance, so I'm going to keep that as d. 1/2. If you don't like fractions, make this 0.5. So I have 1/2. What number am I going to substitute in for a? Because I know the value of the acceleration, and that is 0.25. Don't include the units here because it'll get too messy and it'll confuse us. So that's 0.25. What number do I substitute in anywhere there's a t? And I'm going to put in 120. Again, I'm not going to put the unit. Now, the one thing you have to be careful of is we have to square that. So in our calculator, I'm simply going to multiply these across. I'm going to take 0.5 times 0.25 times 120. I need to square it, so I have to multiply by 120 again. I do this, and I'm going to get, and I get 1,800 meters. All right, let's do another example. All right, once again, I've got our three kinematic equations, and I'm going to start from the beginning. It says a person starts from rest, so that means my initial velocity is 0, and it accelerates at a uniform rate of 3.2 meters per second squared. I know that's the acceleration, both because it tells me it's the acceleration and because the unit is meters per second squared, so I have that value. For a distance of 150 meters, that's going to give me the distance is 150. And the question is, how long did it take? And I'm looking for the time. How much time is it going to take for us to go that distance? So we go through our three kinematic equations, and my initial velocity is 0, so that means I can use the second and third. I'm looking for time, so that's good. I've got the acceleration. My initial velocity is 0, but I don't know the final velocity. This equation won't work. As soon as you have two things that you don't know, two unknowns, that equation's not going to work. So let's go down to this next one. We've got the distance. That distance is 150. 1/2 is just a number, 0.5, so that's never going to change. I know the acceleration. but I'm looking for time. So this is going to be perfect because I have the one unknown. So we're going to use our distance equation again. So I have 1/2 times acceleration times t squared. All right, our distance was 150 meters. That equals 1/2 times my acceleration, and my acceleration was 3.2 times time squared. These terms are all multiplied, all right? So I'm going to take 150 and we'll take what's 1/2 of 3.2, and that's going to give us 1.6 times t squared. All right, I want to get t all by itself, so I'm going to divide both sides by 1.6, and that will give me that t squared equals 93.75. So my calculator says 93.75. But I want to get rid of that squared. I want to find out what t is all by itself. And the way you do that is by taking the square root of both sides. So I'm going to take t equals the square root of 93.75. So you'll need to find that button on your calculator. And I get my time is going to be 9.68 seconds. And that seems reasonable because we know the square root of 100 is 10, so we can kind of approximate that and go, that sounds pretty good. We have an airplane takes off on a runway that is 600 meters long. The plane can accelerate at a uniform rate of 2.5 meters per second squared. What is the velocity of the plane as it takes off? All right, as we've done every other time, let's start with our equations. We have our 3 kinematic equations. Remember, these will always be given to you, so you don't have to have them memorized. We have our 3 kinematic equations. We're ready to solve our problem. We have an airplane takes off on a runway that is 600 meters long. So we know that the distance that the plane is going to travel while it's on the runway is 600 meters. It says that the plane can accelerate at a rate of 2.5 meters per second squared. So my acceleration is 2.5 meters per second squared. And the question is, what is the velocity of the plane as it takes off? All right, so we've got our plane, and when the plane is on the runway, what is the initial velocity of our plane? But our plane is going to take off down the runway. When you're sitting there before it takes off, my initial velocity is 0. So I'm looking for this final velocity as it takes off. All right, my initial velocity is 0, meaning that these two equations are going to work. I want to find out what is that final velocity, v final or v, just plain v. We want to find that out. So let's take a look at this. Let's go to our first equation. And our first equation, I'm looking for that, so that's good. This is 0. I've got the acceleration, but I don't have time. Since I have two things that I don't know, this equation's not going to work for me. Let's look at our second equation. All right, we've got the distance. 1/2 is simply a number. I've got the acceleration. I could solve for time, but that's not what we're asked for. We're asked for velocity, so I don't want to use this one. So let's look at our third and final. I'm looking for that velocity. I've got the acceleration, and I've got the distance. I'm going to use my third equation to solve for this distance. So I've got v squared equals 2 times the acceleration times d. So v squared then is going to equal 2. 2 is just a number. What do I put in where a goes? I put in simply the value of the acceleration, which is 2.5. The distance that it travels is the 600. All I need to do is multiply those 3 values. When I multiply those 3 values, that's going to give me 3,000. But that's going to give me what velocity squared is, and I just want the velocity. So the way we get rid of the squared is we take the square root. We take the square root, and when we do that, we get 54.8 meters per second. So do you see that when I'm doing the math, I'm not including the unit, But where does the unit end up? It always ends up with the answer because any measurement has both a number and a unit. All right, we have a cyclist initially at rest. That means my initial velocity is 0. It accelerates at a uniform rate of 0.5 meters per second squared. What letter are you going to give that 0.5 meters per second squared? The unit should be a hint, and so that tells us it's going to be the acceleration. So the acceleration of my bicycle is 0.5 meters per second squared, which means every second our bike is going to get faster and faster by a half a meter per second. We're going to reach a final speed of 18 meters per second. So that's my final speed is going to be 18 meters per second. And the question is, how far did she travel? So I want to know the distance that our bicyclist went. What is the distance? We have these three equations. This top one doesn't work. I don't have time. The second one doesn't work. I don't have time, and I'm not looking for it, which leaves us with our third kinematic equation, and I have v squared equals 2ad. All right, now we need to start plugging in numbers. What number am I going to substitute in where v goes? And I'm going to throw in the number 18. What number do I put in where a goes? I'm going to put in 0.5. I don't have a number for d because that's what I'm looking for, so I'm going to leave it as d. All right, let's take your calculator. This time I have to remember to square the 18. And when I square the 18, I get 324. Over on the right-hand side, I have to multiply the 2 times 0.5, which is going to give me 1 times d. I divide both sides by 1, and that tells me my cyclist is going to go a distance of 324 meters.